So hi everyone.
Hello. Hello.
My name is Michael, and I'm a GraphQL TSC. So I'm a member of the technical steering committee which creates the GraphQL specification, and I'm one of the main authors of the Composite schema specification that we are at the moment working on. And today we're going to talk about the distributed GraphQL, what distributed GraphQL is, what we mean there, and if you need it, we will discover. So let's talk a bit about GraphQL. So back in 2015, in 2016, around that corner, I was actually contracting for a Swiss insurance company, and they were redoing the whole stack. So they started out and they wanted to build a new customer portal and the backend services for this same customer portal. They also had plans for a mobile application, so we were tasked with designing this backend service that can serve both of these clients. Our front-end engineers back then came from a React conference where they just announced GraphQL, that GraphQL will come out, and Facebook open source basically GraphQL as a specification. So the front-end engineers were pretty sold on GraphQL because it completely changed the interaction that we have with our backends. GraphQL was designed from the first moment for front-end engineers, so for building UIs on top of this backend. And the paradigm shift that we had in GraphQL was about that we are no longer thinking about the technical complexities that we have with getting data, fetching data. There's actually no fetching data if you're building a GraphQL app. You're more concerned with components and data contracts, what data each component needs. And that's really built into the GraphQL specification. So one of these core components that are designed for front-end engineers is actually the fragment. The fragment is our primitive for composition. It allows us to compose data fragments as we can compose UI components. Actually, the fragment is the data contract for a UI component. So if we, for instance, look at this React component, not everybody has to like React, but it's a good example, then you can see up there we have co-located with actually our data visualization code the fragment. So there's no code that actually fetches data. There's just the requirement. This component needs this data to work. And then in the lower part, I just have the HTML code, or kind of HTML code, that uses the data from this data fragment. And that means I can compile this component and I know it will work. I never define anywhere in my application how this data is fetched. There's one place, but in my components, I never deal with the fetching of data. So as we build our application from components, right, stack components together, we by accident actually create a GraphQL query. We're not writing a GraphQL query and fetching data. We're actually building components, stacking them together. And by accident, this GraphQL query happens. And this GraphQL query is actually stacked data fragments together. So let me show you that. So here I actually have the same application. I could run that. Let's see if the web is fast enough. I was warned that the Wi-Fi is not so fast, but you can see, so this application, let's do it again, it has a single GraphQL request that we can see here for all the data I have here. And I didn't write the code to fetch this query, I just stacked components together. Here, for instance, I have the gainers list, there I have a losers list, I have here charts, and up there a ticker. So if I drill into that request, see, let me quickly grab that. So I'm copying that here as a curl command. And then we can paste that in. There. Then I can see that actually my GraphQL query looks like the structure of my components. And let me actually zoom a bit in so you can see better. So up here I have, for instance, a ticker fragment. That is all the data that the ticker requires. Or down here, the feature fragment for the diagrams. And then I have this spotlight fragment, and I can have a look at the spotlight fragment, which is here, which has the gainers and loser fragment for the gainers and losers list. And then I can drill in and see to my smallest component what the data requirements are. So GraphQL completely revolutionizes how we think about data in the front end. And also from the backend side, we don't think about providing you certain requests for certain client use cases. We're thinking about the business model as a whole. So we have this unified API where each client can hook up to and just define the data requirements, and we automatically resolve them. So we are thinking about types, about what types mean in our model, like what is the user type, what is the reviews type, and then the client applications can require data from these types. So GraphQL lets us model an interface to our core business domain. And that is one of the great changes that you have in a predicament shift. And that also, back at this Swiss company, completely revolutionized the relationship between front-end and back-end engineers. Because it essentially removed the tension in the communication. So it was no longer these iterations where the front-end engineer had a requirement and had to wait for the back-end engineer to come up with a solution for that. And then just to realize that it was not how he meant it, or he or she meant it. And then we had to redo this cycle until the front-end engineer was happy. So that doesn't exist anymore, because now you're sitting together with your front-end engineers and thinking about the business cases and design the model how it should be. And then we just define the requirements for our component and everything is resolved. And fundamentally, GraphQL is a monolith. That's also how Facebook started. A big monolith that defines your business model. And while that is a good thing, actually, in the beginning, when we started with the project with two teams, front-end and back-end, that only goes so far, right? In the beginning, we could move so fast because we could refactor everything like we wanted to and just build this application until we added more and more developers. Today, the same company, the same department works with 90 developers on this project. 90 developers on a single data graph, on a single monolith, is not that fun. So we essentially started out at defining our business layer and putting on that a thin layer of GraphQL. And as I said, as we started moving, adding more teams, we started having problems in our iteration speed. Essentially, refactorings from one team bled into the other. Like when we wanted to upgrade the .NET version, that also affected the other team. When we wanted to change types, introduce new types, that also affected the other teams. And that meant we always had to wait for each other. So this was not an ideal situation, and actually then tended us to move slower and be less flexible. It was basically difficult to scale. And we don't mean scale in the sense of throughput for requests, because Facebook, they also have monoliths. They showed that you can actually scale with the GraphQL monolith for 500 million users, right? So that was not the problem. It was a problem of scaling these projects for more developers, for more teams. And that's exactly when you should think about distributing your architecture so you can make space for teams so they can own certain aspects of your backend. So we started rethinking how we built GraphQL, and that was maybe 2016, end of 2016, we started to think how we can make GraphQL more flexible. And we came up with an architecture where we used GraphQL essentially as a gateway for downstream services. So we moved basically the business logic from .NET assemblies into services that we then hooked up to our GraphQL server. So instead of having the logic directly implemented in GraphQL, we moved them a bit outside. And by doing that, allowing more teams to own certain things of our graph. Still, you have the problem that you have the gateway and you have to make up the types. So you have still blocking issues here where you have to wait for one another. Over time, this solution was refined and we introduced a more professional solution where we had these downstream GraphQL services which were stitched into our solution. In the GraphQL ecosystem, we call that schema stitching, and that was the first baby steps towards a proper distributed system. So in this case, you had all the configuration code in your GraphQL gateway, and you would stitch in these downstream GraphQL services. Yeah, as I said, around end of 2016, 2017. And there were a lot of solutions that came out. There were from Atlassian a solution, Apollo Federation. We had our own solution in .NET, and everybody was building something. The problem here is that there was no open standard, and so you couldn't use this cool gateway from this company and stack it together with a composition or a telemetry solution from the other. There was basically no operability, and that started to be a problem. And also, like around patent issues that came up, some companies patented their solutions, so you weren't even allowed to be compatible with them. So that was the time when, around, let's say 2 years ago, when we reached out to a couple of open source companies to band together to create an open standard. And we had a good reception, like companies like IBM, AWS, Hasura, The Guild, and others just joined forces with us to create a new specification. And since January, we are having that in the open. We are in the open working on the Composite schema specification that is owned by the GraphQL Foundation. And that's what I'm going to show you today. I'm showing you the first bits of it, also in a .NET gateway, so there will be code, not just talking. The main ideas behind that approach is that we want to embrace GraphQL, not like the previous iterations that we did when I was contracting at this company, or that others started doing with schema stitching or Apollo Federation. We really wanted to embrace what GraphQL is and create an open source standard that sits right on top of the GraphQL specification. We want to allow any schema that you build as a GraphQL source schema that we could use to build such a distributed system. And we want to support all the GraphQL enterprise patterns and use cases that you have there. So when we look at that picture, what I showed around schema stitching, then we wanted to formalize that more. So we introduced first some terms here, like the gateway schema, that is a composite schema, a schema that is made up of several downstream source schemas. And behind these source schemas can again be microservices or whatever you want to have there. The important thing is that we want to empower your team to build this schema in isolation, but together with others. So the idea is that each team, each organizational unit can own part of the graph. Each source schema is part of the whole. The approach is meant to be collaborative. Collaborative means that we as the company have a common understanding of what the semantics are in our schema. What that means is just we want to have a common understanding what a user is, what an order is, what a product is. because every aspect of this graph is composable. And that means if we have two types across two subgraphs or across two source schemas, like for instance, a source schema is account and a source schema reviews, then these types, if I have a user on both these subgraphs, is the same type. Semantically, the user is the same. And that means we can merge that. I can have the same fields on both subgraphs. These are called overlaps. And I can use them to optimize query planning and things like that. So these types are essentially merged into a single composed type. This is an object composite type. As I said, we have overlaps, like ID and name exist on both graphs, and I can use that for efficient fetching of this data. I also have data that is specific to a certain service, is owned by a team. Like birth date and username is owned by the accounts team, where reviews is owned by the reviews team. And it's evolvable. And that means each team can evolve the type system on their own. So the accounts team, for instance, can introduce here a note field where they want to put in notes. And just deploy that without disturbing the reviews team or asking the reviews team if they could add that. They just can deploy it, the schema is composed, and we have a new composite type here. But if there is any issue, like maybe the reviews team already has such a field, but with a different scalar, then we get compile time warnings, compile time errors that prevent us from even going into the CI/CD pipeline, because that is not mergeable. And then we can, again, it's a collaborative approach. We can go to the other team and say, okay, you have this type or this field. Does it mean the same? And can we get to a common understanding of this field? This approach is explicit. That means we are not guessing things. We are using interfaces and directives to see how these things fit together. Let's actually have a look at it. Let me get rid of this. Okay, so this is a basic setup where I have a couple of subgraphs: accounts, pricing, products, reviews, shipping. And I have a gateway here. The gateway is done. That means there's no configuration needed. We can just start it. So I'm going to do that. .NET run. And then we start basically the gateway. The gateway is hot reload. That means as soon as I'm doing something in the downstream services, it will reflect in the gateway. And then I have here downstream services. One advantage of a distributed architecture is that I can have different technologies in my downstream services. Maybe one team wants to use Node and create a GraphQL server in Node. Then this is fine. I mean, if every team in our company uses a different technology stack, might not be a good idea. But if you have two, might be okay, manageable, and even wanted, because then you can hire from different areas of expertise. So in this case, I have here the accounts node service. It's a typical node service. It uses the Yoga server here and has basically in-memory data. It's a simple demo server here. That's my GraphQL schema. And I can compose that now into that gateway. To compose that into this gateway, I can use the Fusion command line here and just say compose the account subgraph into my gateway. And then this gateway immediately is configured. So I have to do nothing anymore. I can just go to the GraphQL route here. And I'm greeted here by banana cake pop. Let's get rid of that. And I can immediately explore the schema. In this instance, I have a single query type. And actually, let me zoom in. And you can see this schema has a query type. It has a user field, user by ID, user by name, and a users field. So my downstream service is not yet running. And And that's okay. I could still query it. I will get an error if I want to query now the users here, for instance. Let's do that. I will get an error, and users cannot be resolved because the downstream service is not there. But this is okay. The gateway is resilient. If part of the data is not there, it could still yield partial data. In this instance, I just have one service, so I just get nothing. But if you have multiple things and one thing gets down, GraphQL is built to serve partial results. So the gateway is also built to serve partial results here. Okay, let's start actually our downstream service. This is a node service here, so I'm starting that. And actually, let me also start all the others, so I don't have to go back here. This is a .NET service. This is also a .NET service. I walk you a bit through as we go along, so don't worry. Shipping, .NET, run. Okay, so I started all the downstream services, and now from the gateway perspective, I can go back here. If I query that again, so I get immediately the data that I asked for. This is now distributed. This is coming from my downstream service. It's nothing special at this point because it's just forwarding the request, essentially. I also can have a look at what is actually happening here in my system by actually asking for the query plan. Up here we have a query plan tab, can enable that. We run my query, and you can see at the moment we are fetching from accounts and then we're composing the result. So nothing special. So the next thing is, let's add some other data that adds some more complexity here. For instance, let's add the reviews. The idea here is that it's a web shop. We have users, and then we have, for instance, reviews. That are product reviews, reviews about a product in our web shop. And these reviews can be written by users. These are authors. So this should ideally integrate. So we can run the Fusion composition here for the reviews service. Run that. Go back to our gateway. Just refresh the schema here. And then we can see we have now not only queries, we also have mutations. For instance, I can write a review. I can, in real time, subscribe to the review service and get all the reviews that are newly published in real time. Or I can now query my system. And when I go now here to my user type, you can see here this is users. That's what we queried just now. But now I also have here the reviews. That are the reviews of which my user is the author. It's integrated into my type. And if I go in there, I can see I can again page through that. I get the review here, the author, and everything is fine. So let's try that out. So we are going for the username, and then we're getting the reviews. And from the reviews, I'm getting maybe the body. Let's start simple. So I'm running that. And now there's something surprising because we're only fetching from the review service. We're still getting the users, right? But when we looked before, I said something about overlap. So each micro or domain service can have overlapping data. And you're doing that to optimize data fetching. So in this case, we know actually that who's the author of the reviews that we have. And we detected that the name we can actually serve from our review service. So we still can just do it with one hop. So we get all the data that we need to fulfill this request with the review service. So we fetch from the review service, then we compose. The moment I have here some data that is only on the account service, like the birth date from the user, we are actually fetching from more than one subgraph. So we are first still going to reviews because that's the biggest chunk we're gonna get. And then we are merging that with data from the account service. We can also look in detail what's happening. So this is the data. Some users don't have reviews, and some wrote reviews. And if I go down here, this is the query plan actually, which has here the query that we are running. And it also has the query parts that we have. So this is a sequence. We first go to the review service, fetch from there the base query, but we are overfetching here a bit, and we are overfetching by the user ID. I didn't ask here for the user ID, but we are fetching it nonetheless in our gateway. And then we are batching it in a single request to the account service, gathering all the data, merging the result sets, and then delivering the data to our front end. So let's take that a bit further and look actually at more complex scenarios. One second, where am I? There. Okay, so naturally I can compose more things into that. For instance, I can compose here the products catalog into it. And if I do that, I just get now product information here, so refresh the schema, so I could look into what product now this review is about and see what the name for this product is. And when I go here into the reviews, you can see now I have what the review is about, the body, but I'm also having what the product is the review is about, right? And if I look into my query plan, I can see now it's getting more and more complex as we are gathering the data across my company, right? First I go to reviews, I compose that result, then in parallel I'm fetching from products and accounts, compose that again together and have this distributed result. The query plan actually makes it much more efficient as if you were doing that manually, because we have one request still for our client. We have this advantage, there's no over and under fetching from our client side. The client still doesn't care about the complexities about this distributed system. For them it's a monolith. For them they just have this single model of your business. And they just say, for this component, I need the reviews. For this component, I need the user. And behind that, we find out the most efficient way to get all this data and to deliver it to your users. Okay, so let's do one more thing, and then I can actually show you a bit how these GraphQL server look like, and we can also look at real-time data and stuff like that. Okay, so I have another service here, and that is the shipping service. So we're going to look at that in more detail, but let me first compose it just as is. And so this shipping service is actually about an algorithm. It doesn't actually have data. It just has an algorithm that calculates how long the shipping for a product is, depending on the area where you live in. It's totally fake, but it's a good story. So let's say we want to estimate when our product could be shipped to our location. So we have now this field delivery estimate here. And this field delivery estimate has here a zip code. I could put that in, whatever. And then I also need like the size and weight of my product. Actually, the size and weight of my product is known by the product catalog. So I have here a field dimension. And this field dimension has the size and weight of my product. So I, as a front-end engineer, am not interested in this data at all. I just want to know the delivery estimate. And the designer of the subgraph actually exposed that this algorithm needs size and weight to calculate that. So now I could either run two queries here and then put that in, which would not be good, or I could give my downstream service actually some metadata to explain these requirements. So I could go in here and introduce, let's make that a bit bigger, introduce a new schema file. And then I could provide metadata. In GraphQL, we have the extend syntax. So typically we have here the schema. You can see there's a delivery estimate. We have this guy here. That's a product. And we want to extend that with some metadata. So in GraphQL, we can extend our product. So I'm extending that. And then I can add metadata to my arguments. So I could, for instance, say that we require the size here. This is a GraphQL directive, metadata, that I can provide to the composition process of the schema merging. So I'm saying here, okay, this field is a requirement to another service in my distributed system, and it actually needs the dimension of the product. So this requirement is relative to the type I'm extending here. And I can express that I need the dimension and the size here. And I need here the weight. And the actual thing I want to have the user control of is just the zip code and nothing else. So this way I can still design my GraphQL type in C# as if it's a normal method. Then I add some metadata here, and what happens in my public API is actually that we no longer have here any arguments. So let me show you that. So when we go to products here, and we go here to our delivery estimate, you can see that we have only a single argument because the other arguments are actually internal requirements to data from another service. And that means that when I run this query, that it gets a bit bigger. And what we are essentially doing here now, and let's have a look at the detail, is we first fetch from reviews, then in parallel fetch from products and accounts, and then feed in the data, and you can see feed in here the product dimension that is fed into my shipping graph to resolve the shipping estimates. And that basically without any programming of complex data resolver workflows or anything, we just analyze that as compile time. If it doesn't fit together, we would have a compile time error, but with minimal configuration. And let's quickly have a look at the result here. So you can see we have the delivery estimate here. And if we dive into our textual representation of the query plan, we can see here we're doing this overfetch. You can see this requires Fusion Export 3. Fusion Export 3 down here is the product ID to get the products. And then we provide, this task provides 2 and 3, which are actually the size and weight. So we are overfetching from the product graph that. And then we are feeding that into the last data fetch from shipping. Awesome. Okay, let me show you one more thing, and that is actually real-time data. Because like I said, this approach allows you to use any GraphQL feature that there is, and that contains real-time GraphQL. And so far, you didn't see me at any time doing any configuration, because the schema of your subgraph, that is the configuration. And if there is anything complex, like requires or provides, then I can annotate that just for this type. Everything else is inferred from the types, because we have a semantic understanding between the team members what a user means in each of these subgraphs. Okay. So let me just quickly go here to the demo files. No, this one. Demo 2. Okay. Yeah, so I have here a mutation. That's a simple GraphQL mutation, basically doing a change to my subsystem. I can run that, and then I get an error because this product ID doesn't exist. So let's quickly grab a product ID that exists. This one. And we're going to feed that in here. Okay, the author ID also doesn't exist, so I'm quickly fetching also the author ID. So I'm taking this one. Let's feed that in. And then we can do a GraphQL mutation. You can see that is a mutation here. The ID changes a bit. So basically we're adding here these data. So if I query that, I actually can see I have now data here. This guy now wrote a couple of mutations. I can also hook now with real-time data into that and really query things as they come in. So I'm opening here a different version of Banana Kickpop, and I'm hooking into the same gateway. Let me just get that. Okay. And then let me quickly get here the subscription. This is a GraphQL subscription that is essentially a query which is raised and executed every time something new comes in. You can see when I execute that, I'm subscribed here to new reviews. Nothing actually happens because nothing is added to the system at this point. Let me just move that over so I can raise that. So, but in the moment I do this request here, and I could also do some other, let's add some more data here, you can see in real time that the data comes in. This is also with the same distribution engine, just in real time. I didn't configure that because the gateway will inspect your downstream services, no matter which technology, Node, Rust, whatever. We will inspect what GraphQL communication protocol they are implementing, and there are a couple of. Like by default, we are setting that to auto here. But it could be GraphQL over WebSockets, GraphQL over SSE, or the legacy Apollo WebSocket protocol, or soon gRPC streams. And then we are querying your systems in real time. Okay, I'm hooking off that. So the composite schema spec is having a distributed configuration. So each subgraph, the schema of each subgraph, is part of the configuration. And that means I don't have to care about YAML files or whatever. I'm basically writing my schema. I'm writing my GraphQL server in .NET, in Node, in whatever. And the output, the schema file, that is my configuration. It's declarative. With declarative, I mean these directives that I can slap on, like the require directive. I can say, actually, this is not an argument. This is a requirement to data from another service. The composition is done on build time. So when I compile my project, I know if it's going to work in production. And I can also just download the production configuration and compile against that or any other stage. So one of the most important things about this specification is it is open. It's an open source specification under the GraphQL Foundation. The GraphQL Foundation is part of the Linux Foundation, and that means it's MIT, so there's no patent issues or whatever. Every open source developer can implement it if they, he or she want to do that, they can go ahead do that. Any company can provide tooling to it, and tooling is interoperable. These source schemas, these downstream services, can be part of a single overall schema or stand on their own. They can also, oh, I have a meeting. Don't worry. They can also be a part of multiple subgraphs as long as the semantical understanding what the user or what these entities are is the same. As I said, we are embracing all GraphQL features, subscriptions, defer and stream, and what have you there. And we are using overlapping data. Let's just reflect on query planning again. So I showed you a bit the query planning. That's a simple query planning. We are working on something that is called PGO, that is profile-guided optimization in the query planning, meaning that we actually collect telemetry over what you're doing, what the impact is to your downstream system. And then we are looking at what is more efficient to do. So we quickly give you the cheapest query plan, then we analyze in the backend, depending on open telemetry events, what the impact is to your downstream system, and then we are issuing, if it's not the most efficient query plan that you have, a new query plan that has less impact on your downstream system. The first query plan that we do is basically the one with the least amount of hops to downstream services, but in some cases it could be faster to fetch from more services because we're hitting better indexes or whatever there is the case. And that is all also built into the tooling that we have. And this is all part of the hot chocolate GraphQL server. Let me quickly show you. Where are we? Sorry, I put it here on my second screen. Okay, that is, like, let's do that and see if we can show it. Wi-Fi is not the best, so let's quickly give it a second. So we have a complete cockpit that you can hook up your gateway into Banana Cakepop. Unfortunately, not anymore. There. Thank you. Let's see. No. Oh, yes. They sometimes, they on the Wi-Fi mess with your certificates here. I don't know. So let's tether. If not, I have screenshots, don't worry. There it is. Okay, so you get this overview over your graph, how your graph is actually performing, what queries are going through, what clients your graph has. You can dive into the performance specifics around your graph, and you can also control what query plans are we executing, how is the pressure on each of these subgraphs. You can even get an analytics around what field data is expensive. For instance, I can dive into the account subgraph and actually have a look at what the impact is for certain fields. So what are the top fields that cost in my graph? So all this is part of the hot chocolate server. You can also control here the stages. As I said, you could compile against your different stages. This is all up to you. And the cool thing, as this is an open specification, you can use any competitor's tooling on top of that and interchange them. Okay, let's go back to the slides. Yeah, as I said, we baked OpenTelemetry in. So we approached the OpenTelemetry community to have a better semantic specification for GraphQL. And that is basically what we are building our tooling on top on. Let's hop over that. So there's also a nice article by AWS over the composite schema spec, or in particular our gateway. They used that to aggregate actually the AWS Amplify, the AWS AppSync services. And you can have a read. They found out that it's one of the easiest approaches that you can do. And like I showed you, there's IBM, AWS, Azure, all going in to support this specification. So you can also move with your setups from one to the other implementation, or even do your own. So with this, I'm done. If you want to follow me, these are my contact details. Otherwise, I'm open for questions. So,
how's your gRPC support looking?
So it's on the back burner. I hope this year, this first half of this year, we're going to have that. Like gRPC support in general is only interesting in the sense of a composite schema to a subgraph. Like it's not useful from client to the server itself. What we found out is that the streaming is actually the most compelling thing there. If you use actually gzip between your browser and the gateway, it's faster than with gRPC. But between composite schema and source schema is where you get the improvements with gRPC. And yeah, we have that planned for the first half of the year. But it's dodgy at the moment. Any other? Yeah?
Hiya. You mentioned when it's like
when the gateway is building a query plan, that it's able
Yeah.
to kind of semantically determine which service it
Yeah.
can go to get the data. I was wondering, like your example was like, say, between the account service and the review service.
Yeah.
It seems quite likely that you might have a scenario where, say, your review service only contains data about users that have reviews.
Yeah.
Is there a way that you can override that query plan and say, like, the account service has to be the source of truth
Yes.
for the user nodes?
Yes, you can give hints like with more directives. I didn't want to put too much configuration. Like you can get away with a lot without most of the times configuration. But for instance, with the required, I put this hint in. So you need to resolve data there. And you can also say, like my entity resolver, to get the entity's identity, you have to go here. You have to go to accounts, get first the user, even if you don't need data there. Just to make sure this user exists, you have to go there. Yeah.
Cool, thank you. Can I ask another question?
Yeah.
Something that was supported in the hot chocolate schema stitching
Yeah.
implementation was you could have like a nested object in your stitching query. So you could say like a resolver on a certain type is achieved by going to this node in another service and then going to a sub node of that. Will it still be possible to do that in Fusion, or would you have to define the kind of owning type in both services?
You have to, because they are composite types. Like the idea is really that you have a broken graph, essentially. You don't necessarily have to have a C# class. You just have to have this type so we understand the semantics. It doesn't mean this type has to actually exist as an instance. But you have to tell us that this thing that you have there, it goes into this type. So you kind of declare it. But it could also be just in the GraphQL schema file, that it just exists there.
So when you say it doesn't have to exist as an instance, the server could know that it can just create one of these nodes without needing to resolve anything?
And then we would create a pseudo thing and just say, okay, this it's just so the idea is like with schema stitching, it was very much like you're writing a function, and that is very unstable. Where now the semantics between types is very clear, and we know how to compose them. It's much clearer. And also it has a rippling effect. Like with schema stitching, it's just one file, one field where you point to something. Whereas if you integrate it in the type, anywhere where this type sits, it suddenly extends, and in both directions. Like reviews, for instance, suddenly you have the reviews on the user, but you have also the user as an author on the reviews. Like these kinds of things are now much easier because you can essentially say, this is my type and the composition. There are also like just, so this specification is still stage 0. So we are heavily iterating on it together with Apollo. Apollo is also part on the people who are working on that. Maybe Apollo 3 is based on this. The specification, our product is Fusion, but there are others that are also working with us on that. So you can already have a look at what this contains. For instance, if I go here to the source schema, you can already see, for instance, this require directive. But there are also others like override, provides, internal, shareable, or the is directed to give semantics. So there's a lot more that you can hint the schema composition, the more complex your things is. So you can gear it towards certain subgraphs or certain source schemas to say, fetch this thing here. Like the one I told you is this entity resolver, so I can make very clear, this is the entity resolver to get person. So only source schemas that have this entity resolver attribute on, that's where you can get that.
Cool. Yeah, it looks really cool. Thank you.
Other questions? No? Then you can hit me up at the conference if you have more questions, if there's something you want to ask. And with this, we are done. Thank you.